microphone to my co-host. So, Shalom, are you ready?
Yeah.
Yeah.
Hi, I'm Shailaja Kupu. I'm a principal software engineer working for Apple. I'm very happy to speak at the study club today, and I'm happy to share my experience. To give a brief introduction about me, right now I'm working for Apple for developing Cassandra. It's a NoSQL database for Apple's storage. Previous to that, I did work for various organizations like Microsoft, Uber, Bloomberg, NetApp, EMC Square, etc. Most of my experience is in developing highly scalable storage systems, file systems, enterprise level file systems for the organizations, and also developing cloud storage for both Microsoft and Apple. And other than the storage, I also have worked on fintech. I did work on development of the FX trading software for the Bloomberg and also revenue engineering for Uber. Yeah, so both of them, there is a crucial aspect. They have to be very highly scalable, low latency, supporting millions of requests a second, and ensuring 99.999. And we don't know how many nines we need to support, so that's that kind of availability. So today I'm quite happy to share whatever I learned during my work experience with you. Um, so I will first give a brief introduction about what are we planning to do in the study club, what are the contents we are planning to do, and if after that, if there is a sufficient time, I will give brief introduction about why we do system design, how we do that. Once we cover the basic concepts today, we will deep dive into each of the concept, each of the fundamental thoroughly in next upcoming sessions. Understanding these fundamentals is very important before really diving into designing a system, because we need to be very mindful of what are the different alternatives available, what are the trade-offs, what are the pros and cons of each of them, and choose the right one for the design. I will quickly share the screen and show you what is the plan we are having. So if you see this screen, this is a GitHub page which is openly available. I have not written this. This is there from long time, but because this is publicly available, I'm referring this, and also it has references to various good articles and videos and blog posts. So if you want to deep dive, each individual topic is having references to further articles. So first, here, if you see, this is a different concepts we will be covering: system design, why vertical scaling versus horizontal scaling, performance versus scalability, latency versus throughput, etc., availability, consistency patterns, all that. I will provide the link to this in the Slack channel, in our Women Coding Committee Slack channel for the study group. If you're not part of the Slack channel yet, please join that. And if it is possible to share with the meetup as well, I will do that. But I'm not sure. Is there a possibility of that?
Yeah,
Uh,
yes, we will share.
okay. So these are different concepts. It covers end-to-end availability patterns, load balancer, reverse proxy. For example, we need to understand in depth what are the load balancer strategies and load balancer versus reverse proxy. So all these individual concepts we really deep dive into details in the upcoming sessions. So there would be more than these concepts. There are a couple of more modern concepts like WebSockets, etc., which are not mentioned in this article. But once we cover this one, we will cover more concepts. And whenever I do that, I will share you corresponding links as well to reference them. I actually not following the chat group because right now I'm focusing on this one. In case if you have any questions and if I'm not able to address them right now, please reach out on the Slack channel as well. So yeah, how many of you are comfortable with these concepts or aware of these concepts? Uh, it is something very new to you, or you already aware of this but are trying to become expert, get expertise on this one, so you can pass the tech interviews. I just like to get an understanding to see how fast or how depth do I need to go. Yeah, that's good. So some of you are new, some of you are a bit familiar, some of you are already good enough in this one. I will assume that everyone is a pretty new and dive each and every concept. And even for those who already having understanding of this, probably I can help here by giving few practical examples and or depth, because I have a practical hands-on on these systems, because we do work on scalable storage systems. We do, for example, in the replication as well, we do implement synchronous and asynchronous replication. So we really have a good way more understanding about when to use what and what are the problems with this approach more practically. So probably I will be able to help you by diving deep into that. So you can keep that in mind. But if you want to really move faster, so I need to keep others also in the mind and need to cover everything from the scratch. So now I will give a very brief introduction about the system design, how you need to approach it, and why. This is my screen, Excalibur. So in a system design interview, we need to drive the discussion. So it's not like a where coding interview where someone asks you the question, you give some answer, they ask you to optimize it, and we do more. Whereas in case of system design, you need to be you need to believe yourself like a founder of a startup. You're developing a system all the way from the scratch. So you need to think through different options available, alternatives available, trade-offs, pros and cons, and choose the right one suitable for your application. There is no single right and wrong answer. For example, if you take the strong and eventual consistency, for some applications, eventual consistency is good. Nothing wrong in that. For some applications, strong consistency is good. So for the problem in hand, we need to think through what is the right one and why do you want to go through that. So to the interviewer, you need to explain what are the options available, pros and cons of that, and why are you choosing one over the other. To be able to do that, you need to really have all the fundamental concepts, in-depth understanding. The one contents page I share right now, for each of the topic, you need to have a in-depth understanding. Let's assume that we are starting a startup. You're all the founders along with me. Now we develop a small application. 1 minute. And because we are in the early stage, we just starting with a database, and we are having a user table in the database. And this works fine as long as we have very few number of requests and very small user base. There's nothing wrong in that. For our situation, for our scenario, for our application at that time, this is the best approach because there is a low cost and it is serving the purpose. Now let's assume we are getting really popular. Let's assume our app, something like messaging app, XYZ, it really getting popular and we are getting more number of requests, more number of users are hitting our system. In that case, we need to improve because this database is unable to scale to that number of requests. So it's lagging behind, our latency is higher or unable to support the throughput, etc. In that case, typically what we do, we add more CPUs, more memory, so that this machine works more performant. For example, if this database is having if this machine is having a 1 or 2 cores, you probably add more cores and more RAM. Let's assume from 8 GB to you are increasing to 256 GB, the highest less this machine is supporting. This is called vertical scaling. That means to the same machine, you are adding more and more power. While this works to some extent, probably we were serving 10 requests per second previously, probably after upgrading your machine, you're supporting maybe 20 requests per second, but you can't scale for that because there is physical limitations. Even whatever is this, even if it is supercomputer, there is a physical limitation. The number of CPU cores that machine can support, amount of the RAM it can support. It's a typical, even in the laptop, the amount we can add, how much we can upgrade. There is literally physical limitations. That is one problem. There is another problem. because we have only one database, one machine. Let's assume we are having our machine in a typical data centers kind of small center, and that got lost. That lost the power. So this machine is down. In that case, our entire application is down. We are unable to serve any of the incoming requests because our system is completely down. So there is another problem with this. This is the availability. The availability of the system is not guaranteed all the time. And when it is down, we are our application is not taking any incoming requests. That is another problem, availability and the scalability. The first one, where we have limitation on the number of requests we can serve, that is the scalability problem. Sorry for my handwriting. And the second problem is availability. How much time it is up and serving requests, even in this case of disasters, etc. And then the other problem is because only one system is serving the request, the throughput is going to be less. That's like you can say that the throughput is number of requests the system can support. So in the throughput, for example, if previously before vertical scaling, if it was supporting 10 requests per second, we call that throughput is 10 requests per second. Let's assume after adding more power to this machine, we are supporting 20 requests per second. Then this entire system's throughput is 20 seconds per second because there is only one machine and that machine's throughput is 20 requests per second. This is called throughput. Then the latency. Latency is how much time does it take for serving one request. For example, previously before adding more cores, if only two cores were at the operation, then only two cores were serving the request. Then the one request probably was taking to let's assume 10 milliseconds to serve one request. For example, I say that in my chatting messaging application, okay, get my older message. In that case, probably it was taking 10 milliseconds to go and retrieve that information from the database and show it to the client. Now, maybe because we added more cores, probably the latency improved a little, maybe to 12 milliseconds. The latency goes down when we improve it. So 8 milliseconds to serve one request. So this is the latency. So because now with this vertical scaling, because we are hitting the hard limits, we go for the horizontal scaling. There is another problem with the vertical scaling that I have not covered, the price. For the vertical scaling, because we are trying to make a single machine more and more power by adding more cores and RAM to make it like a supercomputer, the cost is going to be really high because we need to buy very higher end hardware to support this one. So the cost is going to be really high. Now, this is the reason we go for the horizontal scaling. So with the horizontal scaling, instead of making single machine as a powerful, we have normal commodity machines. These are not supercomputers. The typical daily regular using machines are maybe because enterprises can afford probably a bit more powerful, but need not be a costly supercomputers. But we take multiple such machines and split the data or distribute our data into multiple machines. This is called horizontal scaling. Now, when you're distributing the data into multiple machines, we call it as the sharding. So that means we are having a strategy how we wanted to split this data into multiple machines, and we will deep dive into the sharding and different strategies for the sharding and what is on what basis should we choose which approach, etc. in the upcoming sessions when we deep dive on the sharding and partitioning. Right now, we can just assume that sharding or partitioning is a way of splitting the data into multiple machines. Now, because we are having multiple machines, now we can serve multiple requests. Each machine can serve requests. Now, if you see, Each machine is working in parallel. So none of them is blocked on the other one. Each machine is able to independently serve requests. Because of that, this machine's throughput goes up. For example, if this machine, which is not a supercomputer, is able to serve 10 requests per second, then this one also serving 10 requests per second. This one also serving 10 requests per second. Our throughput went to 30 requests per second. So if you see, for the same cost, probably we are achieving higher throughput. Instead of adding more cores and more RAM to the same machine, instead of making a single machine powerful, probably with the almost same cost, we bought normal commodity machines, more than one, and making each of the machine work in parallel. That way, we are achieving higher throughput per second. And because now the one problem we are seeing with this one, right? Because the horizontal scaling is complex, we need to implement additional approaches, strategies to make it working. Now users, we don't let users to directly hit our machines because for the privacy and security. So, and also there need to be a strategy on which machine to serve what requests. So we introduce a load balancer. Again, in the load balancer, we will deep dive in data about the load balancer. What is the use of it? What are the different policies load balancer can implement? How is it ensuring the security, etc. All that. In the upcoming session, we will be having a one particular session just for the load balancer and the reverse proxy. We will deep dive on that. Right now, we are in high level. Just assume this load balancer taking incoming requests from the clients, and it knows how to send a request to which machine. In the backend, we have multiple machines, and the client is not aware of that, and load balancer is taking care of distributing this one. So we have to introduce the load balancer, and then this one becomes highly scalable, mainly because if we have more requests, let's assume our application is super powerful and we are competing with Google, for example, just assume, then we add more machines. Then when we have more machines, we have to distribute the data further. But when we get into the sharding and partitioning, we will discuss about different approaches. How do we migrate the data? How do we ensure whenever we add a new machine or whenever the one machine is down, how are we migrating the data to ensure the availability is still maintained? That we will be discussing in upcoming sessions. So when we add more machines, our throughput is also going up. Uh, so this is how we do more. We do scale more and more with the horizontal scale, horizontal scaling. Now we are having the scalability problem fixed with the horizontal scaling, and throughput is also handled because of the scalability. Now, how availability is going to be supported with this one? Let's assume this machine is down. This data center has gone down. Then we will serve the same request. The load balancer detects that this machine is down. There are different strategies. We will deep dive into that and sends those requests to other machines. It could be different machine as well. So when this happens, the whatever data we lost on this machine need to be available in other machines. So we do use replication. Replication means we keep a copy of the same data on other machines as well. For example, this one is a copy of the other machine. This is a copy of another machine. So in replication also, there are different strategies how we want to do the replica. Is it a synchronous replication, asynchronous replication? Why do we want to go for which one? How do we replicate? And what if this data on this machine is not yet available for the other machines to replicate when the system is going down? Then we do go through the journaling records, write ahead log records, etc. So these are the further concepts where we will have a separate session for the replication, deep dive, and with example, we will show when one machine goes down, how other machines are taking the requests, how are they ensuring those machines are serving the latest data instead of the stale data. So the replication will be introduced with this one. And now because we are having replica of the data, availability is going up high. Because, for example, if this machine is going down, those requests are served by other machine. If this machine's data is available by more than one machine, for example, this is also going down, then those requests can be served by this machine. That means our availability of the entire system is going to be quite high. So we will have one session to calculate availability and latency throughput, because in the system design interviews, these numbers also we need to calculate and show the to the interviewer. And based on how much availability, scalability we need also should be able to calculate how many machines we need. How do we want to go for a database? Do we want to go for a typical disk-based system, or do we want to go for SQL database or NoSQL database? All those will be decided based on how much scale and availability we want to support. So we will go to replication as well in upcoming sessions. And now, if you see in this simple example, we have taken a database, and always database is going to hit the disk to read and write the data. So if you want to reduce the latency means the time, as I discussed previously, how much time to serve one request. So for example, a request is going here, going to the disk database, reading from the disk, then the disk is because it's slower, we will be having higher latency. To reduce the latency, we introduce a cache. Cache is an in-memory system. There are key value stores. There are more complex caches as well, with ensuring persistence like Redis cache or just memcache, which is just always in memory. So where we will have one session on the cache as well, to explain cache, their cache writing strategies like write ahead, write through, etc., and also key value stores and different types of key value stores available right now in the market, which one to use in which scenario. We will have one session on that as well. So we will have the cache, and we serve the request from the cache whenever the data is available in the cache. If the data is not available in the cache, that's when we go and hit the database. That means we try to reduce the latency wherever possible. So this is a typical, very high level system design. There are many more concepts to we explain in each of them, and fundamentals in deep. Need to dive deep into them. So for each of the topics, we will have a separate sessions. Let me know based on this, how does it look like? So is this something you are looking for, or do you want to just directly jump into the mock, or do you want to directly just go into the each and every topic in detail in each of the next upcoming sessions? So I just wanted to hear from you your opinion.
I think, can I just ask you a quick question, Shailaja?
Yeah, go ahead.
You explained how horizontal scaling solves a lot of problems. My question is there any scenario where vertical scaling is even preferred?
Yes, that can be. So I did, because I did work in both scalable and low latency systems. There are some systems which they do both. In fact, just vertical scaling only doesn't solve the problem, but they do vertical scaling as well. For example, in the fintech systems, the financial systems, the trading systems, which have to be very, very, very fast and has to be very low latency, because the trades have to go. For example, if you take a XYZ company stock price is falling down, then people want to immediately go and buy them. So they have to be very quick, the trading systems. For them, they do go for the vertical scaling as well. They do have a very higher end machines. In fact, I have even seen the companies who employ their own networking cards as well across the globe. For example, from US to another country, they do have their own private cards as well. So those are the very specialized, very low latency systems. They do both, but just vertical scaling is not sufficient, because they have two problems. One is they need to be very fast, and also they have high scale, because they are hitting many millions or maybe billions of requests per second. Then you do both vertical scaling as well as the horizontal scaling.
Thank you. That makes sense. Sorry, you said you use some word. They have private cards. What is that?
I mean, the network, for example, is the internet we get. That those internet probably for some fintech companies, even that is also slower. They probably employ, I don't want to name any company, I don't want to mention anything particular about maybe it's under my disclosure as well, but there are fintech companies who have their own internet networking as well to let their requests serve faster.
Right. Okay, makes sense. Thank you.
So those are like very specialized. They need both horizontal as well as the vertical scaling. For example, if you take Hadoop, SGFS, Hadoop, it runs on a just normal commodity machines. It doesn't need to have a special machines. It doesn't need to go for vertical scaling because it's designed that way to have a more availability. But it's a bit slower compared to enterprise kind of storage systems. For example, if you take a Google Spanner or something else, those are very, very fast. They do even have flash to write. Not even disk is slower for them. They do have flash attached to the data centers. So they are doing vertical scaling. That means they are making each and every data center very powerful. At the same time, they are doing horizontal scaling because for they have such a huge user base and so many requests. They have to employ both of them. But for the same company can implement different strategies at different layers. For very mission critical systems, they do both horizontal vertical scaling. For the data which doesn't need to be mission critical, for example, analytics in the background, analytics at the backups, etc., probably they will go for the typical Hadoop for the commodity software. So the same employer, sorry, same company probably implementing different strategies for different kind of data. For the older data, probably they just go for normal commodity machines. For the machines which are serving the incoming requests, and they probably go for both vertical and horizontal scaling. We actually, once we are done with the fundamentals, we will go for a couple of real world designs. For example, design of Cassandra, design of DynamoDB, etc. And in those cases, we will show how these are really implemented in practical. Because what we discuss, what we design in system design is a typical basic one compared to enterprise level. But actual organizations, they do implement all the different strategies we do mention, but they do implement different strategy for different scenario, different application, different data center based on how mission critical it is.
Shailaja, a quick question. Thank you. I think your format that you have suggested is pretty good, and also deep diving into the topics are very useful, in my opinion. One question I have is, based on your experience, when you went through these system design interviews, have you ever come across a situation where they say, oh, you have overcomplicated your design? You did mention that the solution is in the final solution doesn't matter. The way you have approached the problem is what is more important for the interviewers. But would there be a situation where they say, oh, although you have solved the problem, your solution is overly complicated? Have you come across the situation, or have you given a feedback to any other candidates like that?
No, I'm not that straightforward. Even if it is complicated, I wouldn't say that, to be honest. But what usually do system design interview, there are two different kind of audience we are having. So the system design, not everyone need to be really interviewing here. So probably they need to learn to really design their own system. For example, just don't worry about attending interview and passing it. Just think through having your own startup, develop your own system. In that case, the system design concepts are really useful, right? So you can be audience for being a founder of a startup and developing your own system as well. Coming to the interview is, to be honest, it depends on the expertise of the interviewer as well. I don't blame them, but if interviewer itself is not that expertise or not having exposure to the real very practical systems in depth, then probably they themselves not expecting too much details as well. So that's the reason what we usually do in system design interviews. We first go at the breadth. We don't jump. For example, if in this case, if you take the load balancer, we don't directly jump into load balancer strategies, which one to choose, etc. We will say that we are going to have a load balancer. We are going to distribute the data, and this is our high level system in breadth. That's when interviewer, based on his interest or his or her interest, they can probably choose to go in depth into particular component. If someone is interested in understanding but solving a particular problem in the load balancer, they may zoom into that particular area more. Someone probably is more interested in the caching or sharding, they may zoom into the other concept. Usually interview is just 45 minutes after introduction. So in the 45 minutes, definitely we cannot go into the deep dive of each and every topic. So interviewer usually chooses where they want to deep dive. So in the interview, we usually go at the high level, just show the breadth. This is how it's going to be. When interviewer questions you in a particular area, that's when we explain more details. That is not just because interviewer's choice, but sometimes we may not have a sufficient time to deep dive into each one of them. So I see this kind of problems. Some people just keep going to depth and depth in particular area, and they don't get time to cover up the breadth. So that's when we need to hold them. Okay, first let's cover up the breadth. Then if the time suffices, we can go and hit the depth. Or sometimes some people just go at the breadth and they just stop there. So that's when we don't know how much understanding they have in each of the system. That's when we tap into more in particular area. So we ask, okay, I understand this sharding is fine, but how do you want to shard your data? What is the strategy, etc. So that's when we go into further details in particular area. That's the reason, first give a bit high level breadth and let the interviewer to ask you where they wanted to go in depth. If they don't have any choice, then you can go for whatever your comfortable level, or just go a little depth into each and every component and see if you're still having the time.
Can I just add to Rashini question? It's a good one, actually. From my experience, so there will be, when the system design is interview started, you're usually gathering functional and non-functional requirements, right? So your non-functional requirements will actually dictate how the system design will go. I have experience in I saw I was making mistakes in the past as well myself, and I also saw these mistakes from different people. So, for example, when you're not defining the non-functional requirements, and when you not ask whether this app will be used as an internal one or it will be a global scale. So this is the mistakes where you go horizontal or you go vertical, or you will use cache or you won't use cache, where you will use CDN or you don't won't use CDN. And it is quite frequently that you will come to the interview, even for fund companies, and we are not, it could be that they won't ask you about a global scaling, and they will ask you just to design some internal application. And that's where, with correct questions, you will show your seniority and experience. So basically defining these non-functional requirements, and then to say, hey, there is like 100 daily active users. Why I would have? That's how, I was in this situation multiple times. So also like, and if candidates want, and if interviewer want, he could evolve. So, for example, he would ask, okay, now we have 100 daily active users. Let's now scale to 1,000 or 1 million, what we will do. So, it's you should have this in mind always.
Thank you. Thank you very much.
So adding to that, in the non-functional requirement, functional requirements, so better you try to cut off unnecessary things there itself. For example, if someone is asking you to design in a messaging app, Because definitely the time is not going to be sufficient enough, you can say that do we want to support messaging in the groups, do we want to support media videos? So probably for the interviewer they can say that okay, just keep it simple plain messages one to one. And once you solve that problem, that's when the interviewer can ask you if the time suffices to deep dive into how do you support your system for the groups and the media, etc. In fact, that is how you need to design your own system as well. So when you're starting your startup, it doesn't directly go into all the features in one shot, right? You first add one feature, then based on the popularity and the requirements, you add more and more. So that's how you need to do in the system design as well. In the requirements itself, try to make it as basic as possible by negotiating with the interviewer. Once you solve that problem, if the time suffices, that's when we go for the advanced ones.
We have a couple of questions on the
Yeah, I'm looking at them.
yeah.
I'm looking at them. Something happened to my window. Yeah, and now it's back.
Ekaterina is asked, in the horizontal scaling example, what are the difference in the event bus versus IP calls in the context of latency and scalability? Not quite understood the question. Katerina, could you, if you could unmute and ask?
Yeah.
Sure.
I was just curious in terms of the whole layout, if there are big differences that influence scalability and latency, depending on how you implement technically. Of course, I know there are differences, but yeah, I was curious as you had all the system laid out, how it would influence it. What's the biggest differences in the choices?
So the question is differences between scalability and
latency effect on scalability and latency if you choose event bus, if you choose API calls or other ways to communicate to your backend, to your database.
I think
that we will go in the deep dive sessions on the client interactions, because right now we are just at the breadth and we don't want to overwhelm with all the concepts in one shot. Let's go in the structured way. So once we have we will inform you each and every topic for the next Sunday. For example, actually I forgot to mention, we are planning to take turns, 1 week me and 1 week Ilya. So the next Sunday, if Ilya is planning to take sessions, and what is the topic she's going to deep dive, and if I'm going to take at least 1 week before, we will inform either through Meetup channel. I'm not sure because I'm presenting first time in the this community as a study club. So we will either inform in the Slack channel or in the Meetup. We will inform you what is the topic we are going to cover, and we also give you corresponding references. If you want to read upfront, you can read upfront and come back. You can do other way around. After the session, you can go and read it. That I would usually recommend, because once I give you the fundamentals, when you go and read it, you will understand better instead of reading upfront.
Okay, thank you. Great, thank you.
there is another one question. Do you want to take, or you have something to share?
No, I'm not sharing because I'm just going to the questions. I don't want to overwhelm on the first day, so I don't want them to run away, to be honest. So the next, I'm just going to the questions. Do you need load balances for vertical scaling? This question, if you are having only one machine, you probably don't need a load balancer at all, because you don't have any request to be spread across different machines. But if there are multiple machines and each machine, vertical scaling is not against horizontal scaling. These can go along as well, together as well. For example, let's just assume that you start your startup. Initially you got one machine, and because you want to scale, you added 2 more machines. Now you got 3 machines, and while serving the requests, probably you want to improve the performance of each and every machine and replace them with a powerful machine. So you still can have vertical and horizontal scaling, but we usually say vertical scaling versus horizontal scaling to show that what that vertical scaling alone cannot solve, and why we usually go for horizontal scaling. but you can do both together as well. It's not against each other. But if you need more than one machine serving the request, then you need to have a load balancer or the reverse proxy, which is a more simplified one compared to load balancer. Load balancer is more powerful and more, it is having more features. You can have a reverse proxy. There are open source free reverse proxies as well. So we will evaluate when features of each both of them and when do we go for which one. And would be yes, we will share online resources and docs. We are not doing the PowerPoint presentations because we are very busy entire week working in the corporates, and the weekends we do spend on this one. And also making PowerPoint presentations where the system design is very difficult because we need to make many architectural diagrams. And also I feel whiteboard sessions are more better because we can show you why and how the flow is changing. For example, the way I showed you right now. And then
yeah, in my opinion, also system design is whiteboarding station instead of PowerPoint. So we also will keep sharing some useful resource, which is usually used. So and yeah, and we will
another question. So technically the buffer pool layer in the DB is in memory and has frequent queried hot data. If we are going to add another cache layer, does this not duplicate effort in memory part of database? Okay. So I can answer you this, but ideally we deep dive into this in the database section. We do deep dive SQL, NoSQL database, write ahead logging, etc. How databases do that. I did work on the development of the file system for the database, for Teradata database, and also now working on the NoSQL Cassandra. Yes, databases do implement the cache. They try to keep the recently read data into the memory wherever possible. And they also try to do like most of the metadata in the disk, and also the write ahead log, which is also kept in memory to see what is the recent data, recent work going on, etc. But what database is doing is nothing to do with your application. So databases are designed to be general purpose. But on top of that, with this, we still do the caching and our key value stores. If you take an example, for example, if you are serving your Facebook kind of app and you are having a profile page, and when a user X, let's assume our popular user, let's assume Trump, for example, his profile always need to be in memory because it's very popular. It's very popularly visited page, and that we usually keep it in a cache. Whereas the database has its own caching mechanisms. It doesn't understand your application requirements. It cannot differentiate which user is special, which user not special. So database is the optimizes mainly for its own read and writes, not for the application. Whereas our caching extra layer is customized for our application. So that's the reason. And also usually is a database, there can be multiple instances of the database. For example, database 1 probably serving users profiles. Database 2 probably serving messages, recently written messages, recently exchanged messages, etc. So there can be multiple databases. And in the key value store, you probably having all this customized together, stitched together to serve a Facebook page. So your caching layer is customized for your application, whereas database is particular for the data it is storing and reading and writing. It doesn't customize for your application requirement. Did I answer? Otherwise, in the deep dive sessions, we will go with examples on this one. Why do we do this extra on top of that?
Can I also add? So basically, this is also a very good question, and it has a point. So you're not always having this cache layer. When you have database, there is not obligatory that you need to have cache. So it's also trade-offs where you're taking this decision to have. So for example, if you serve request, which is you can actually static, and you have static information, which is your serve, and there is latency aspect that you want to serve it as quickly as possible, then you would put this layer. But if you serve request, which is not statical, it's dynamically changed, there is no papers to store this cache layer to have this. And a lot of applications just don't have them. Some application who is literally serving the static content, they have this. And cache we usually have in order to reduce the latency, because database is stored is placed on the one machine, and cache usually placed on the another machine, and the purpose of the cache is to place as closer to users as possible.
Okay, so I'm going for next questions. The other question is, so coming to real world examples, as someone asked, we first cover the fundamentals, then we go into the real world examples, because just going to the design of a Cassandra probably just takes one session, but each and every step has lot of depth and details. So first, understanding the fundamentals in depth will help you understand the real world designs, why it was designed that way, what was the trade-off, etc. So the fundamentals probably will be covered in a couple of sessions, maybe around in optimistically in 10 sessions, or in the worst case maybe in 20 sessions. After that, we will go into the real world examples, we'll explore them. And also we also do mock design a couple of our own systems as well, because just instead of just reading through existing ones, if you design your own systems, then that's when you will feel confident about your understanding. Once we are done with the exploring the real world examples, I would easily encourage you to have mock sessions between you. All mentees can form a group of a few people each, and then have a mock sessions between you. That way you can practice the system design, not only that, and also the interviewing and the communication, everything. Mentors maybe may not be always available for you to take mock sessions for each and every one, but if you can make a group of 2 to 3 people each and do the mock sessions between you, that would be very helpful for you. And then yeah, so coming to system design books and everything, so I see most of the books are directly jumping into mock system design, but no, then it becomes very difficult with doing that without understanding the fundamentals. So once we are done with the fundamentals, then we do go through the real world examples. That's when we can do the mock systems. At that time, we can look into the good books as well and explore those designs as well. So that's the reason I have not restricted the study group to just few months or a few sessions. There are no number of limited sessions, not limited to number of weeks. We can keep doing as long as we want to, and more designs we can keep exploring after covering up the fundamentals. Coming to the depth, some people may need just moderate depth. Some people need already who are having experience may need more in depth. I will try to be as depth as possible during the fundamentals, because you need to understand them very well. And I will try to show them with examples so that everyone can understand them. If you don't want to go into the depth, you can skip those off of the session after that, or you can just skip them wherever you want to. But I try to be as much depth as possible, because we are trying to address broader audience here. Are there any questions that I missed?
No, I think we took all the questions. Folks, if you have, we still have 4 minutes more. Otherwise, we can, yeah.
So I see many of you mentioned that new or beginners. So what I mentioned, what I tell you, right? Just don't feel yourself that I'm new to this. This is something complex or something, but just assume that you are starting your own startup and you want to learn everything, how to learn and explore. That's when you will learn many things well. And always don't worry about the interview perspective. Try to do something on your own, and like is having your own idea implemented. Doesn't matter is it if failing or working or not working. Even in the failure, you will learn many things. I did see someone mentioning doing this as a mini project. To be honest, system design is very, very vast and breadth. You can't really just implement everything in any limited time amount of time. Even if you see the organizations, they took decades to come to this to the scale they are supporting now. Even then, they are not perfect, of course. So it's not possible to have entire system design implemented, but for each and every individual concepts, there are many open source versions. You can check out the code and see how are they implemented. For example, if you see reverse proxy, there are reverse proxy open source code. You can check out the code and see how it's working. And if you see NoSQL databases, there are open source versions like Cassandra, everything. You can check out and see. Even for the key value stores, Redis, there are open source versions. You can check out and code and see. Even just checking out the existing code and trying to understand it is going to be very difficult. Probably after this session, after completing the system design study club, I can run another study club to go through the various open source repos and let you help you understand the code. But it's very difficult to understand. If you check out the Cassandra code, it takes years to understand that code, to be honest. Nowadays, the good thing is we are due to AI, there are various tools like Cursor, a ChatGPT. When you in the Cursor, when you check out a repo, and there is a way to ask the Cursor to help you understand a particular class, file, and code path. You can check out the Cassandra code and say that help me understand the read path, help me understand the write path. So you can take advantage of those tools. Previously we were not having that as well, so it was very difficult to understand because those are very complex. Actually, Ilya, I think if anyone is good in using the cursor, someone can give one session on the women coding community, how to use the cursor to understand the open source coder, and that would be helpful for everyone to use the tool well.
Which one you mean?
The Cursor is a tool which is available freely, and we can check out a repo and ask the Cursor to help us understand the code.
Oh, really? And I even haven't heard it. So we can think. Yeah, you will show me, and we will think. Yeah.
I didn't really try hands on that, but yeah, I can try to do the hands on show you at one point of time.
Yeah. Oh, thank you.
Yeah. So are we done? Are there any questions?
Just to add Lilia and Shailaja, I think there might be some women I know who have experience of working on Cursor. They might be able to support this.
That would be very helpful. The more help we get to the community, it's more helpful for the mentees.
I haven't used. Yeah.
You can reach out to Ilya or Rajeshri. They can help you organize one session, a couple of sessions
Sure,
on them.
I'll just share their names and then you could take it ahead.
Yeah, so we are out of time. Let's see next week with a new topic. We will inform you the topic. Maybe I think the next session is probably Ria. So maybe she will announce in a couple of days, I guess.
Yeah.
Yeah.
Thank you.
Thank you. That was
Thank
wonderful.
you.
Have a good evening, folks. Thank you for joining us.
Bye.
Thanks all. Thank you. Bye-bye.
Bye.
Thank you.
Thank
Bye.
you. Bye.